Good morning students. Let us start with next module of this chapter. Today we are going to discuss about distance and displacement for a circular path because we have left with circle and rectangle for calculation of distance and displacement in my last module. So let us start with this situation. Consider a circle whose diameter is 14 meter and therefore its radius becomes 7 meter. So we are going to discuss about two cases, case number 1 and case number 2. Case number 1 is related to calculation of distance and displacement for one complete round. So one complete round will be from A to B, again back to A. So this will be one complete round. So we have to calculate distance and displacement for this. And second situation is case 2. For half round we have to calculate S and S vector. Obviously half round will be from A to B only. So let us start. So for first case, when distance is to be calculated, as we are moving along the boundary of the circle, therefore distance will be equal to circumference or perimeter of the geometrical figure. Obviously the circumference or perimeter of circle is 2 pi r, that you all know. So we have inserted all the values and we have got this value for distance calculation. If you want to calculate distance for number of rounds, then keep on multiplying this 2 pi r with number of rounds. Say if you are going to calculate distance for 2 rounds, then multiply this 2 pi r with 2. If you are going to calculate distance for say 100 rounds, then it should be multiplied with 100. If you are going to calculate it for 2.5 rounds, say, then it will be multiplied with 2.5 and so on. So if you know the circumference, then you are able to calculate distance for each and every case, each and every round. Now come to displacement. Displacement S vector will be 0 because last time also we have discussed that initial point when becomes same as that of final point, done already. I have written that also. So when initial point becomes same as final point, then displacement will be 0. Why? Because you have not at all displaced from your original position. Your original position was A, and via you are traveling this circle to point B and coming back to point A, so therefore there is no displacement, as initial point was A and final point was also A. So I am repeating this point again. Displacement becomes 0 only and only when initial and final points are same. That we have done in triangle also. Now let us come to another case, case number 2 for half round. When a body is moving from A to B, just half of the circle is travelled by the body. Since this is half of the circle, so distance will be any long path. It's a body's choice whether to move from A to B during this while this curved path, or he or she can choose any zigzag path for reaching A to B. So let us come to the calculation part for half round from A to B. From A to B, the body has chosen A to B, this curved path. This is actually half of the arc, semi-arc. So this arc is actually what? This is the half of circumference. So we have written over here, this is pi r. So this pi r becomes equal to 22 meter, which is exactly the half of 44 meter. Now let's come to displacement part. As I have told you earlier also, displacement is the shortest path. So from if a body wishes to reach from A to B, it has many options from A to B, but the shortest path is just A to B. It's his or her choice. I am repeating it again. He can or she can take any of the paths, but the shortest path will be taken as displacement. So A to B is the shortest path, which is equal to diameter. So for calculation of distance, we have written displacement is equal to AB, which is the shortest path, and that is equal to diameter. So with this we have completed the problem for a circle. You can see it once again, or let me know if you have any problems. In next video we will discuss about rectangle and square problem.